5054, uh, October, November 2021, paper 2, variant 2. And the topic is nuclear physics. Uh, in the alpha decay. Question number 6. Isotope X is a radioactive. It decays by alpha particle emission to a stable isotope. एक आइसोटोप है एक्स रेडियो एक्टिव है अनस्टेबल है उसमें से अल्फा इमिट कर रहा है और वो एक स्टेबल आइसोटोप बन रहा है स्टेट हाउ a nucleus of X changes when it emits an alpha particle. एक्स में क्या चेंज आ रही है जब उसमें से अल्फा पार्टिकल इमिट हो रहा है. We know the X is an unstable and it split into two daughter nuclei and one of the daughter nuclei is an alpha particle. So that means the unstable nucleus is converting into an stable daughter nuclei. So what happens to that nuclei? The parent nuclei X is split into alpha and another daughter nuclei that is reduced by two proton and two neutron. तो जो दूसरा न्यूक्लियाई होगा वो स्टेबल होगा और उसके पास दो प्रोटॉन कम होंगे एक्स से और उसका न्यूक्लियन नंबर 4 होगा माइनस पहले वाले आइसोटोप से 4 न्यूक्लियन नंबर कम होगा क्योंकि उसके पास से दो न्यूट्रॉन एंड दो प्रोटॉन निकल चुके हैं. The daughter nuclei will reduce by two protons, right? Z minus 2 it becomes and nucleon number A minus 4 it will become. There is question number part B. There is a radiation detector in a laboratory where there are no radioactive samples. The detector is switched on and shows an average count rate of 22 counts per minute. State why the radiation detector shows a count rate. So it's due to a background radiation. We are under influence of background radiation all the times from the concrete, from the mountains, from the cosmic rays. बहुत सारे इसकी सोर्सेज हैं जहाँ से हमें बैकग्राउंड रेडिएशन मिल रही है बट द रेडिएशन इज वेरी स्मॉल इन अमाउंट सो वो हमारे लिए इतना हार्मफुल नहीं होती बट जो कॉस्मिक इनमें से जो कॉस्मिक रेज हैं वो ज़्यादा हार्मफुल उस वक्त से होती हैं कि जब हम बहुत हाई ऑल्टीट्यूड पर होते हैं जब हम बहुत ज़्यादा एक्सपोज होंगे कॉस्मिक रेज की तरफ से राइट सो द रेडिएशन फ्रॉम द mountains, rocks, concrete, cosmic rays. So among them, cosmic rays is have more contribution due to it's coming from the cosmos, or and even then it is not so hazards, but having hazard, but continuous exposure like a passenger traveling very frequently from the high altitude that might have that person might have some problem due to that background radiation. Part 2. A sample of isotope X is placed 2 centimeters from a detector and the reading displayed as 8,000 counts per minute. The sample is moved a distance of 10 centimeters from the detector, the reading returns to an average value of 22 counts per minute. Explain why the reading returns to the original value. We know the alpha particle has a very few range in air, very few centimeters, right? Because it is absorbed by air. So that means by placing away from the source, it will not enter to the detector, so detector cannot measure, right? So only the background radiation it will count. So alpha particle cannot travel more than few centimeters and absorbed by air, so that is why the detectors only count the background radiation. An alpha particle passes into a region when there is a magnetic field in the magnetic field, a force on the alpha particle. So an alpha particle passes into a region when there is a magnetic field in the magnetic field. A force acts on an alpha particle so that it follows a circular path, shows a particle passes through point G. We know the part when a trajectory is circular, so the is acting towards the center. So draw an arrow through point J to show the direction of the force of an alpha particle at J. So this is a sort of alpha particle, right? Trajectory, and this is the circular trajectory supposed to be. So the and the force is always perpendicular to the center of any point, so F is directed toward the center. So this is the direction of the force. Next, determine the direction of the magnetic field and the mark a tick in the box that indicates its direction. So as the alpha particle moving up, right, moving up, so that means the magnetic field is into the page. ठीक है, is into the page. आपने फ्लेमिंग लेफ्ट हैंड रूल को अपने लिए इसका एक टोटका बना लेना, लाइक कि if your first finger represent the direction of the magnetic field and the second finger is represent the direction of gamma ray, then the thumb will surely represent the direction of alpha particle. अगर आप इस चीज को ध्यान में रखें तो you will get easily memorize easily that. So explain whether this force does work on the alpha particle as the particle moves along the circular path. Means work done हो रही है क्या नहीं. So for work done, the condition is very simple. The force and displacement both are should be in the same direction. Here you could see the particle is moving in a circular direction and force is focusing at the center. So that means force and displacement are not in the same direction. Therefore, no work.